Welcome to another deep dive.
Oh, it's great to be here.
Today we're looking at Solidity.
Okay.
You're interested in, how to write cleaner, more efficient code.
Yes.
And, how to write clean code for Solidity. This guide is a great place to start, and our deep dive today is going to help you create those super secure contracts everyone wants to see.
Absolutely. Clean code, it's not just about making it, look pretty or anything like that. It really has an impact on the reliability and security of the whole system.
Right.
Which is super important in this world of blockchain, right?
Right. Yeah, no do-overs in the blockchain.
Once it's deployed, that's it. No going back.
This guide's going to help us lay that unshakable foundation for your contracts. But before we get into all the cool stuff, the design patterns and gas optimization,
Right.
I feel like a quick Solidity refresher is in order.
Absolutely. So when we're talking about Solidity, it's specifically designed to create these smart contracts that run on the Ethereum blockchain.
Okay.
And the blockchain world throws some unique challenges our way.
Right.
For instance, each execution has a cost, which we call gas.
Oh, okay.
Plus, once a contract is deployed, it's virtually impossible to change.
Yeah.
So, efficiency and security are things we need to think about from the very beginning.
Yeah, gas is like the fuel for your contract's actions on the network.
Exactly.
Every single thing your contract does, storing data, running calculations, all of it uses this gas.
Right.
Writing clean code that's optimized for gas usage
Yeah.
can be a real money saver.
It can, and it's not just about the money.
Right.
Inefficient code can lead to bottlenecks, even security risks,
Oh, okay.
which is something we definitely want to avoid.
Yeah.
So,
The guide really stresses that security is not an afterthought.
oh, absolutely not.
It needs to be built into your code right from the start.
From day one.
We're dealing with valuable assets here,
Yeah.
and one tiny vulnerability can have a huge impact.
Exactly. You can have the strongest door in the world, but if you put a flimsy lock on it,
Right.
it doesn't matter how strong that door is.
Right, you got to have those high security locks in place.
Yeah.
Okay.
From the beginning.
So let's get into some of the specifics. So for those just starting out with Solidity, the guide does a good job of, running down all the core elements.
It does.
It mentions that Solidity syntax is similar to languages like C++ Cent,
Yes.
which can be, helpful for some developers, but it has its own unique features too.
Absolutely. I mean, there are definitely familiar elements. You have your data types, you have your variables, your control structures.
Okay.
But then there are things like the address data type, which is unique to identifying accounts on the Ethereum network.
Right.
And then you have this whole concept of events, which are signals that your contract can emit to notify external systems of what's going on.
Oh, okay. So it's like your contract is sending out a little signal flare saying, hey, something just happened here.
Exactly. It's a way for contracts to communicate, not just with each other, but with the outside world.
Okay.
So now that we have the basics down, we understand the importance of gas, we understand the importance of security. Let's talk about writing these clean contracts.
Okay.
And the guide really emphasizes keeping things simple.
Okay.
And, A, B, C, you would know what to put in.
Yeah, you'd have a bad cake.
Clear descriptive names for your variables and functions. That's like built-in documentation within the code itself.
Right.
So anyone can easily understand what's going on.
Yeah, it's like leaving notes for your future self.
Exactly.
You're coming back to that code later and you're not scratching your head like, what was I doing?
That's right. And speaking of things we want to avoid, the guide talks about staying away from global variables.
Why are those so bad? It seems like it would be easier to access information if everything was global.
Well, global variables can actually make your contract's behavior harder to predict and understand. And remember, on the blockchain, everything's transparent.
Oh, right. Yeah.
Global variables can be accessed, potentially even manipulated by anyone.
Right.
So there are definite security risks if you're not really careful with how you handle them.
Yeah, I see your point. It's about, making sure you're creating a more secure foundation.
Exactly.
Making sure your code isn't vulnerable.
Okay. Along those same lines, documentation, super important.
Right.
It might seem obvious, but well-commented code can be a real lifesaver.
Right.
When you explain the purpose of your contract, the different functions, and all the key variables, it not only helps others understand your logic, but also serves as a guide for yourself when you come back to the code later.
Right, like those breadcrumbs in Hansel and Gretel.
Exactly. You don't want to get lost in the woods.
You don't want to get lost. All right.
And speaking of things that can help you avoid getting lost, let's not forget about error handling.
Oh, right.
The guide emphasizes handling errors gracefully
Right.
instead of letting the whole thing crash and burn.
So it's like having airbags in a car.
Yes.
If there's an accident, those airbags deploy and prevent a lot of damage.
Exactly.
So graceful error handling is like creating those safety nets within your code to help prevent catastrophic consequences.
I like that analogy a lot. It's about making sure that even if something unexpected happens,
Okay.
the contract fails in a predictable way.
Right.
So that you or someone else can understand what went wrong and fix it.
Okay, so we covered a lot of great stuff so far.
Yeah.
You know, keeping things simple, meaningful names, avoiding those global variables, having that documentation, and then implementing graceful error handling. But what about testing?
Testing.
How do we know that these beautifully clean contracts that we're creating
Right.
actually work the way they're supposed to?
So testing is absolutely essential, and the guide talks about several different testing strategies.
Okay.
Unit tests, for example. Those are looking at each little piece of code in isolation to make sure that it works correctly on its own. Then you have integration tests, which take those individual pieces and make sure they all work together as a whole system.
Okay, so it's like making sure each ingredient in your cake recipe tastes good on its own.
Yes.
And then making sure they all combine to make a delicious cake when you put them together.
That's a great way to put it.
Okay.
The guide also mentions code coverage testing, which helps identify any parts of your code that might not be adequately tested.
That sounds really helpful. Are there specific types of code coverage testing that work particularly well with Solidity?
Yes, there is. It's called fuzz testing, and it's specifically designed to throw random, unexpected inputs at your code to see if it can handle it without breaking.
Oh, wow. Okay.
Solidity is used in these scenarios where you don't necessarily know what the inputs are going to be. So fuzz testing is a great way to test your code's resilience and try to catch any vulnerabilities early on.
Okay. This is great information, and I feel like I'm starting to get a really good understanding of what clean contracts are all about. Clarity, efficiency, and reliability.
Absolutely.
But we're not just building these contracts for ourselves, we're building them for other people to use.
Yeah.
How do we make sure they're easy to use and maintain? Is that where design patterns come in?
Exactly. Design patterns, think of them as pre-built blueprints for solving common coding challenges.
Okay.
They're like proven recipes that experienced developers have used and refined over time.
So instead of reinventing the wheel every time,
Right.
we can use these proven patterns
Yeah.
to save ourselves time and effort.
Exactly.
And our code will be more robust too. Sign me up.
I know the guide goes into some specific patterns that are especially relevant to Solidity. Can you give us a preview of those?
Sure. One that's really popular is the factory pattern, which is basically like having a master blueprint for creating new contracts.
Oh, okay. So instead of writing the same code over and over again for each new contract,
Right.
we can use a factory to automate the process.
Exactly. And it also makes your code more modular and maintainable. If you need to make a change to how the new contracts are created, you only need to update the factory instead of every single individual contract.
Oh, that's brilliant. What about updating existing contracts? Is there a design pattern for that as well?
There is. It's called the proxy pattern. And it's a game changer when you're working with the immutability of the blockchain. What makes it so great for the blockchain and that immutability?
It basically acts as a stand-in or a proxy for your actual contract. All the interactions happen with the proxy, which then forwards them onto the real contract behind the scenes.
Okay.
This allows you to update the logic of your contract without changing its address,
Okay.
which is really important when it comes to interacting with other contracts or users.
So it's like having a receptionist who can direct calls to different departments,
Yes,
but the caller only ever sees the receptionist. I like it.
exactly.
Are there other useful patterns like the factory and proxy that we should know about?
There are a couple others that the guide mentions. The state machine pattern is a good one for managing the different states within your contract.
Okay.
And then you have the circuit breaker pattern, which can help you handle critical failures more gracefully. And we talked about graceful error handling earlier. And the circuit breaker pattern kind of takes it a step further. It's all about making sure that your contract fails in a way that minimizes any negative consequences.
Okay, I'm really starting to see how important these design patterns are for building, well-structured, robust contracts. But there's another important aspect we need to consider: state and storage.
Right.
I know that storing data on the blockchain comes with a cost. How do we manage that efficiently with Solidity?
It does.
Oh,
That's
yeah.
a great point. Remember all that talk about gas earlier?
Yeah.
Well, every piece of data that you store on the blockchain costs gas. So minimizing storage usage is really important for keeping those costs down.
So it's like packing for a trip.
Yes.
Right. You want to bring everything you need,
Right.
but you don't want to overpack and end up with a heavy suitcase.
I like that. And the guide actually gives some tips on how to pack efficiently in Solidity. First, consider your data types. Fixed-size data types like June 256 are generally more efficient than variable-size ones like strings.
Oh.
You also want to think about using data structures like structs and mappings to organize and store your data efficiently.
This is making a lot more sense now. We're keeping things simple, we're using meaningful names, we're making sure to document everything properly, we're thinking about security, how to handle errors gracefully, and we're even exploring these design patterns to make our contracts more robust and maintainable. But I know we're just scratching the surface here. There's so much more to explore when it comes to writing clean code in Solidity, like optimizing for gas and diving even deeper into all those important security considerations.
There is. You're absolutely right. We've laid a good foundation, but there's much more to discover.
And that's what part 2 is for.
Exactly.
See you there.
See you there. Welcome back. Last time, we laid the groundwork for clean contract development in Solidity, exploring the importance of clarity, efficiency, and security.
Right.
Now, let's turn our attention to gas optimization,
Okay.
a crucial aspect of writing efficient and cost-effective smart contracts.
So it's like we've built the car and now we're figuring out how to make it fuel efficient so we can go further on a single tank of gas.
Exactly. Minimizing gas costs is essential.
Right.
It makes your contract cheaper to use, and it prevents potential bottlenecks on the Ethereum network.
Okay.
And our guide, How to Write Clean Code for Solidity, suggests several techniques for achieving this.
Okay.
One approach is using inline assembly for low-level optimizations.
Inline assembly. Sounds pretty intense. Is that something that every Solidity developer needs to know?
It's more of an advanced technique. You're basically writing code that interacts directly with the Ethereum virtual machine, the EVM,
Okay.
which requires a deeper understanding of how the EVM operates.
Right.
But the potential gas savings can be significant, especially for performance-critical operations.
So it's like fine-tuning your car's engine for maximum performance.
Yeah.
You wouldn't necessarily do it yourself unless you really knew what you were doing.
Right.
But it can make a big difference in how efficiently your car runs.
Exactly. Now, for those who prefer a more high-level approach,
Okay.
the guide also recommends avoiding costly loops,
Okay.
especially those that iterate over large data sets.
Yeah, I can see how that would eat up a lot of gas. Are there any specific alternatives to using loops that we could, give an example of?
Absolutely. Let's say you need to find a specific piece of data within a large array.
Okay.
Instead of using a loop to search through the entire array, which can be very expensive, you can use a mapping.
Okay.
Mappings are like dictionaries,
Right.
where each piece of data is associated with a unique key.
Right.
So instead of searching, you can simply access the data directly using its key.
Oh, okay.
Much more efficient, uses far less gas.
Yeah, that's a really clear example. So instead of going through every single item in a list one by one,
Right.
we're using a shortcut to jump directly to the information we need.
Exactly.
I like that. Are there any other gas optimization strategies that the guide recommends?
Yes. The guide also highlights the importance of using gas-optimized functions whenever possible.
Okay.
Solidity has several built-in functions
Okay.
that are designed to minimize gas consumption for common operations.
Right.
For example, instead of using a manual loop to add up all the values in an array, you can use the sum function, which is specifically optimized for that purpose.
Oh, okay. So it's like choosing the energy efficient appliance over the one that guzzles electricity.
Yeah,
You're getting the same result, but with a much lower energy bill.
exactly.
I like it. So we've covered some great strategies for gas optimization, using inline assembly for those advanced optimizations, being mindful of those costly loops, and making use of those built-in gas optimized functions.
Yes,
I feel like we're well on our way to creating some really efficient smart contracts.
absolutely.
But now let's shift gears and talk about security.
Yeah?
As we discussed earlier, security in Solidity is absolutely paramount. How do we build contracts that can truly withstand those attacks?
Security is definitely something we can't afford to overlook.
Right.
And one of the key takeaways from the guide is that while Solidity itself is designed to be a secure language,
Right.
vulnerabilities often arise from the way developers implement it.
So even with the best tools and materials, if you don't build a house properly,
Exactly.
it's still going to be vulnerable to the elements.
Exactly. We need to understand the potential pitfalls
Right.
and make sure that we're building our contracts with security in mind from the very beginning.
Okay.
The guide dives into some of the common Solidity security vulnerabilities.
Okay.
Reentrancy attacks are a prime example.
Yeah.
They're pretty nasty.
What makes reentrancy attacks so dangerous?
Well, a reentrancy attack is where a malicious contract tricks your contract into calling it back repeatedly,
Okay.
draining its funds before it even realizes what's happening.
So it's like a thief using a stolen credit card to make a bunch of small purchases really quickly
Yeah.
before the bank can flag it as fraudulent.
Exactly.
That's a good way to put it. How do we protect our contracts from these types of attacks?
One common technique is to use a mutex. It acts like a lock,
Okay.
preventing multiple transactions from modifying the contract state at the same time.
So only one person can enter the room at a time, so to speak.
That's right. And it prevents that malicious contract from repeatedly calling your contract and draining its funds before the first transaction has a chance to finish.
Okay, got it.
Another common vulnerability is integer overflow and underflow.
Those sound pretty technical. Can you explain them in a way that's easy to understand?
Imagine you have a glass of water
Okay.
and you keep pouring more water into it.
Right.
If you pour too much, it's going to overflow.
And make a big mess.
Exactly.
Yeah.
Well, integer overflow and underflow work in a similar way.
Okay.
If you try to store a value in a variable that's too big for it, it can overflow and wrap around to a very small number,
Okay.
leading to unexpected and potentially dangerous behavior.
So how do we prevent these, overflows from happening in our code?
Well, Solidity has some built-in safeguards to help with this. The safe math library, for example,
Yeah.
provides functions that perform arithmetic operations safely. They check for potential overflows and underflows before they happen,
Right.
preventing those unexpected errors.
So it's like having a safety valve on a pressure cooker.
Exactly.
Okay. The guide also talks about security audits.
Yes,
It seems like those would be essential for any serious Solidity project.
absolutely. Having a fresh pair of eyes, ideally from experienced security professionals, review your code
Yeah.
is invaluable.
Right.
They can spot potential vulnerabilities that you might have missed.
So it's like getting a home inspection before you buy a house.
Yes.
You want to make sure there are no hidden problems lurking beneath the surface.
Exactly. And security audits are especially important in the world of smart contracts because remember, once a contract is deployed, it's very difficult to change.
Right.
So those audits give you the confidence that your contract is secure and can withstand those attacks.
Right. Okay, so we're being mindful of those common vulnerabilities. We're using tools like SafeMath to prevent those integer overflows and underflows.
Yes.
And we're seriously considering those security audits. This is great information, but now I want to talk about the tools and resources
Okay.
that can help us in our Solidity journey.
Sure.
There's a whole ecosystem out there for Solidity developers, right?
There is. The How to Write Clean Code for Solidity guide gives us some great recommendations for tools and resources that can really streamline our development process
Okay.
and help us write better code.
All right, great.
One of the first things the guide mentions is IDEs,
Okay.
which stands for Integrated Development Environment.
I've heard of IDEs. They're basically code editors with superpowers, right?
That's a good way to put it. IDEs like Remix and Visual Studio Code, they provide a whole suite of features
Okay.
that make writing, testing, and debugging your code a lot easier.
Right.
It's like having a high-tech workshop
All right.
with all the tools you need to build your masterpiece.
Sign me up for that high-tech workshop. But what if you're not quite at the masterpiece level yet?
Right.
Are there tools out there that can help you write cleaner code
Absolutely.
and catch those potential mistakes early on?
Absolutely. The guide recommends code quality tools like Solvent and Solium.
Oh, okay.
These tools act like your coding buddy,
Right.
gently nudging you to follow best practices
Okay.
and keeping your code clean and consistent.
They're like having a spell checker for your code, catching those typos and inconsistencies before they become bigger problems.
Exactly.
I like it. And what about security? Are there tools that can help with that too?
There are. Security auditing tools like Mithril and Slither can help you identify potential security vulnerabilities in your code before they turn into real-world exploits.
Okay.
It's like having your own personal security team,
Right.
constantly scanning your code for any suspicious activity.
So those security auditing tools are looking for things like reentrancy attacks and integer overflow vulnerabilities, the things we talked about earlier.
Exactly. They help you catch those potential problems before they cause any damage. But it's not just about the tools, right?
Right.
The guide also stresses the importance of connecting with the wider Solidity community
Right.
and tapping into the collective wisdom of other developers.
Yeah. There's nothing quite like learning from those who have been there before. What are some of the ways the guide recommends doing that?
There are a few really great resources out there.
Okay.
The Solidity documentation is like a gold mine of information,
Right.
providing all the details you need to know about the language and how to use it effectively.
Okay.
It's like having a comprehensive encyclopedia at your fingertips.
Right.
And then there's the Ethereum Stack Exchange,
Okay.
which is a community-driven Q&A site where you can ask questions and get help from other developers.
So it's like having access to a whole team of expert consultants ready to lend a hand whenever you get stuck. That's amazing. Are there any other resources that you think are worth checking out?
Yes. The guide mentions Open Zeppelin, which is a library of reusable security-audited smart contracts.
Okay.
These are pre-built components that you can use in your own projects, saving you time and effort,
Right.
while also benefiting from the expertise of the Open Zeppelin team.
So it's like having access to a library of prefabricated building blocks that have already been rigorously tested and certified for safety.
Exactly.
That's a game changer for developers of all levels.
Absolutely.
What about style guides? Are there any that are specific for Solidity?
There is. The Solidity Style Guide provides a set of guidelines for writing clean, consistent, and readable code.
Because even the most brilliant code can be difficult to work with if it's not well formatted and organized.
Exactly. It's like having a style guide for your writing.
Right.
It helps you create code that's not just functional,
Okay.
but also aesthetically pleasing and easy for others to understand.
Right.
And of course, no Solidity journey would be complete without checking out the Ethereum white paper.
Is that the document that started it all?
It is. It's like peeking into the minds of the creators.
Yeah.
And understanding the original vision behind this revolutionary technology.
Yeah.
It can be pretty dense and technical, but it's a fascinating read for anyone who's interested in the deeper history and philosophy behind Ethereum and Solidity.
This has been an amazing deep dive. We've covered so much ground.
We have.
From gas optimization
Yeah.
and security best practices
Right.
to all these fantastic tools and resources that can help us write cleaner, more efficient, and more secure Solidity code. But there's one more piece of the puzzle that we haven't talked about yet. Testing.
You're right. We've touched on testing a bit,
Right.
but there's a lot more to explore when it comes to testing strategies and best practices for Solidity. That's what we'll be focusing on in part 3.
I'm ready to test my knowledge. See you there.
See you there.
Welcome back to our deep dive into the world of clean code in Solidity. In the previous parts, we've covered a lot of ground, from the fundamentals of Solidity and the importance of gas optimization to those critical security considerations and all those fantastic tools and resources that can help you write better code. And now, in this final part, we're going to shift our focus to testing.
Yes.
Which is, an absolutely essential aspect of building reliable and secure smart contracts.
Absolutely. Testing is, so often overlooked.
Yeah.
But it really is the cornerstone of any robust development process.
Right.
And it's especially important in the world of Solidity because once a contract is deployed to the blockchain, it's very difficult to change.
Right.
So, finding and fixing those bugs early on is absolutely crucial.
So it's like making sure your spaceship is in perfect working order before you launch it into space.
Exactly.
You don't want to discover a problem when you're already halfway to Mars.
Exactly.
Yeah.
And our guide, How to Write Clean Code for Solidity, provides a great overview of different testing strategies that can help us ensure our contracts are rock solid.
Okay.
We've briefly touched on unit tests and integration tests before.
Right.
But let's dive a little deeper into what those actually involve.
Sounds good. A refresher is always helpful.
Absolutely. So unit tests, think of those like putting each little piece of your code under a microscope,
Okay.
making sure that they work correctly in isolation.
Okay.
You're testing individual functions, making sure that they produce the expected output for a given input. It's all about verifying those smallest units of your code.
So it's like testing each individual component of a machine before you assemble the whole thing.
Exactly. And then you have integration tests, which take those individual units and put them together, testing how they interact with each other. So it's like taking that assembled machine for a test drive, making sure all the parts work together harmoniously.
So unit tests make sure the wheels spin. Integration tests make sure the car can drive.
A perfect way to put it.
Yeah.
And the guide emphasizes that both unit tests and integration tests are crucial for building reliable and secure smart contracts. But there's another type of testing that's particularly relevant to Solidity. fuzz testing.
Yeah, we talked about fuzz testing briefly earlier. It's all about throwing random, unexpected inputs at your code to see if it can handle them without breaking, right?
That's right. And it's really important in the world of Solidity because you don't necessarily control the inputs to your contract. Anyone can interact with it, and they might not always provide the inputs you're expecting.
Right.
So fuzz testing is like stress testing your contract,
Right.
making sure it can withstand those unexpected situations.
This is all incredibly valuable information, but testing can feel a little overwhelming,
It can.
especially for those who are just starting out with Solidity. Are there any tools or frameworks that can help us with this testing process?
Absolutely.
Yeah.
There are several great tools out there that can make testing much easier and more efficient. One popular framework is Truffle,
Okay.
which provides a development environment specifically for Solidity, including testing capabilities. It's like having a dedicated testing lab for your smart contracts.
Oh, okay. So it's kind of like having those crash test dummies
Yeah.
for your car.
Yeah.
You can put your contract through all sorts of simulated scenarios to
Yeah,
see
that's
how
it.
it holds up.
Exactly. And another great tool is Hardhat, which is another popular development environment and testing framework for Solidity. It offers a lot of flexibility and customization options for your testing setup.
So it's like having a more advanced testing facility
Yeah.
where you can customize the crash tests
Yeah.
to simulate specific, real world conditions.
That's a great way to put it. And both Truffle and Hardhat integrate well with other testing libraries and tools,
Okay.
allowing you to build a comprehensive testing suite for your Solidity projects.
So we have a variety of testing strategies at our disposal: unit testing, integration testing, and that all important fuzz testing.
Right.
And we have some fantastic tools like Truffle and Hardhat
Yes.
to help us automate and streamline the process.
Yes.
This is all great stuff. But what about best practices? Are there any specific tips or guidelines that we should keep in mind when writing tests for our Solidity contracts?
Absolutely. One key principle is to keep your test as simple and focused as possible. Each test should really target a specific aspect of your code, making it easier to understand what's being tested and to pinpoint any issues that arise.
So it's like breaking down a complex problem into smaller, more manageable chunks.
Exactly. And it's also important to make your tests readable and self-explanatory. Think of your tests as documentation, providing insights into how your code is supposed to behave. Use clear and descriptive names for your test functions and include comments to explain what's being tested and why.
So our tests should not only verify that our code works correctly, but also help others understand how our code works.
That's right. And another important aspect is to aim for high code coverage. This means testing as much of your code as possible, leaving no stone unturned. This helps ensure that you're not missing any potential bugs or vulnerabilities.
So it's like having a thorough inspection of your house, checking every nook and cranny for any potential problems.
A perfect analogy. And thankfully, there are tools that can help us measure code coverage,
Right.
providing insights into which parts of our code are being tested and which parts might need more attention.
This is all incredibly valuable information, and I feel like we're well equipped now to write those comprehensive test suites for our Solidity contracts.
Absolutely.
But as we wrap up this deep dive into clean code and Solidity, I want to step back for a moment and reflect on the bigger picture. Solidity isn't just a programming language. It's a tool for building a more decentralized and transparent future.
It is, and the code we write today will have a real impact on that future. It's crucial that we approach Solidity development with a sense of responsibility, knowing that our code could be used to handle valuable assets, to facilitate important transactions, and to power innovative applications that could change the world.
And the principles of clean code that we've been discussing throughout this deep dive: clarity, efficiency, security, testability, all play a vital role in building that responsible and sustainable future
Absolutely.
for Solidity and the blockchain ecosystem as a whole.
Absolutely. Clean code isn't just about making our lives easier as developers.
Right.
It's about building systems that are reliable, secure, and trustworthy,
Right.
which is essential for fostering wider adoption and realizing the full potential of blockchain technology.
This has been an incredible journey, and I want to thank you for sharing your expertise and insights with us. We've covered a lot of ground, from the fundamentals of Solidity to advanced concepts like gas optimization, security best practices, and those all-important testing strategies. And we have explored a wealth of resources that can help anyone on their journey to becoming a better Solidity developer.
It's been a pleasure diving into this topic with you. And for our listener out there, I encourage you to continue exploring, keep learning, and never stop striving to write cleaner, more efficient, and more secure Solidity code.
And remember, the principles of clean code aren't limited to Solidity.
Right.
They apply to any programming language.
Yes.
And can benefit any developer who wants to write better code. So take what you've learned here and apply it to all your coding endeavors.
Happy coding.
That's it for this deep dive. Until next time.